Who's ever heard of Albert Gonzalez? Not Adrian Gonzalez, but Albert Gonzalez. Anybody? A couple people?
Yeah, he became an FBI, what do you call it, cooperation?
Yes.
They gave a lighter sentence, I think.
Yes. So Albert Gonzalez was basically the the ringleader for the TJX and the Heartland payment fraud that happened a few years ago, and widely known and shown that was 170 million cards that were compromised because of him and because of his teams that were dealing with this fraud. So there's people out there do this, and also the Targets and the Home Depots. I think a lot of us heard of that a little later. And locally, we've got a grocery chain called Schnucks that was targeted a couple years ago, and so it was really big here in St. Louis because it was local. It was hit home, and fraud has really taken lots of different steps. So before, years ago, I think when I first came in, the big thing was SQL injection, right? People were stealing stuff through websites and where 1 = 1, semicolon in, select star from credit card table, and it would all return back. Well, luckily, the industry's gotten a lot better at a lot of those things, and we don't deal with as much of that, or hacking URLs and going to somebody else's account. A lot of that doesn't happen. None of that's not out there, but for the most part, a lot of that doesn't happen anymore. So now, hackers have gotten smarter. They get into the POS device, the point of sale device where you swipe your card. And so they're not reading off a disk anymore or out of a database or out of a flat file. They're taking just memory because that's somewhat stored, somewhat unencrypted. So they're sitting there taking all this memory, just blindly taking memory. And then after the fact, they go through and go, what looks like a card number? This looks like a card number. This looks like an expiration date. This looks like magstripe data. So they start taking that. So they're just blindly taking stuff in some cases, and that's how they're starting to get their cards. And they can do that, as we've seen, without anybody even noticing for weeks or months or sometimes even years. They're sitting there just taking cards over and over and over again. So about a little more than a year ago, MasterCard announced this product that we were starting called SafetyNet. And it's a product where we can look at transactions globally and try to find this fraud that's being attacked, either our processors or for merchants or anybody else that's getting attacked. We can kind of see a global view of that and be able to stop that before the banks or the cardholders even know that it's happening. So that's kind of a big thing that was announced a little over a year ago. And so I was brought in I was not a performance engineer, but I was brought in to take a look at the environment and to try to make sure that we can perform at a level that we can do this all real time. So as cards are being swiped, we can take a look at those cards, we can analyze what's going on, we can look at history traits of the card or the region or whatever it might be, and we can make determinations and stop the fraud before it even happens. So that's a big project that's been going on with MasterCard. And so one thing I want to talk about is kind of what I've learned over my past year working with this and trying to get our platform to tens of thousands of transactions per second, all measured in tens of milliseconds. So it was a big effort that went through to get us there. So I'm going to talk about 3 guiding principles, and I'm going to finish up with 3 good steps to get this through to your managers on things that you might find. So who in here has had a great idea? Hey, this is a performance issue that's in my application, and I need to fix it. Your manager goes, I don't got time. We don't have to do that. Who's had that great idea? I've got an idea, but they don't want to work on it, right? There's some reason they don't want to do it. Well, the last 3 things, all this should kind of revolve around that. But then my last 3 steps are good guiding principles on, how to do that, how to show your manager, here's the problem, here's the solution, and what do we do next, okay? So my 3 guiding principles here that I've kind of noticed as I've been moving through this is, the first one is tiers, second one is tools, and the third one of my favorites, strategery. Now, strategery may not be in the dictionary, but it was coined by a great theologian, Will Ferrell, in Saturday Night Live when he was imitating a previous president of ours, but that president used it in his administration quite a bit after that episode. So strategery will be our last one. So our first principle, tiers. So a lot of times you're forced into tiers or layers or whatever you want to call it in your application. You might have a web tier, you might have an application tier, you might have a database tier, and a lot of bigger companies might force you into that, right? And so we may already be doing this to a little bit, but there are also times, especially when this platform was originally built, which was, maybe 8 years ago, we thought we needed to kind of combine things. We still were kind of centralized. Let's put everything together and make everything, work faster, because usually, historically, the slowest piece of our application is what? The I/O, right? It's the I/O. Don't go to disk, don't go to the network, don't do any of that, right? It's slow, 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 don't do it. And we needed to be fast, fast, fast. So kind of the original thought was to kind of lump everything together or make it kind of centralized. So this is obviously an extreme approach, but everything was on a physical server. So our platform has a bunch of different tiers in it, a bunch of different pieces of things that happen all in tens of milliseconds to say, hey, this is fraud or this isn't fraud or this is kind of the level of fraud that it might be, so we can all make decisions at that point. And so this can sometimes work really fast at low transactions, at low volume. It can work really, really fast. But when you try to ramp that up and you really try to get some volume going through this, you're going to have a lot of bottlenecks, right? You might have one tier that's a bottleneck. So maybe my rules engine is a bottleneck. It's very CPU intensive. It can only do so much, but other pieces of my application are taking away CPU from my rules engine. So it can't ever live to the levels that it can live at because other people are even holding him back. And some of these things have license fees and different things like that we have to deal with. And so if I can't really utilize the license that I've installed on my server, then I'm wasting money. I'm wasting time and money and everything else. And then if we need to grow the capacity, if we need to scale this at all, it can be a headache in a couple ways, right? I mean, we've got to reconfigure every single tier in our environment. We have to redeploy everything. We've got to make sure everything's running on this thing all the time. And it didn't really work. We had a hard time scaling this years ago. And so we obviously went to more of a tiered approach where we put all the like processing, we distributed like processing on separate physical machines. So we moved our rules engine to its own server. We moved our database to its own server. We had an analytics tier. We had a management tier that kind of dealt with how to move this transaction through its life. And this made it a lot easier to scale, right? Because if my rules engine was my, I needed to scale my rules engine because it wasn't performing like I wanted it to, then it was easy. I just had to add a rules engine. Everybody else stayed the same. And my only licensing came from a rules engine. It made it very easy to scale. So a tiered approach is when you really need to scale up and you need to get a lot of transactions, a lot of throughput, is a great approach. So our second principle is tools. And one of the big tools in your performance environment should be your test environment, right? And we all know that we want our production environment to look exactly like our test environment, right? Not at all right? It never happens, it never works. I don't even want it. I mean, I don't know how many servers you might have in your environment, but if you have tens or hundreds of servers in your environment, in your production environment, think about how hard that is to manage. I don't want to manage that in my performance environment either. It's near impossible. You can't get the data right, you can't get the servers right. It never, ever, ever works. It never equals each other, and nor do you probably ever want them to equal each other. It's always too much money to do it, and it takes way too much time, too much effort, too much configuration. So we know that that's really not realistic in most any environment that you want. So a couple of things that we did to try to fix this is we created just a small sliver of what our production environment might look like. So we tried to deploy everything to somewhat like physical machines. We tried to make the network the same. We tried to do as much as we could. Didn't always work, but we tried to do as best as we could through that. And one of the original testing methods that we're working on and was working on right when I first started was just an end-to-end testing approach. So we had this whole environment set up. We could always run transactions through it. We kind of said, okay, we're going to run X TPS, 500 or 1,000 TPS through this system and make sure it looked at least as good as it looked before, right? And it helped a little. I mean, it found the big things that were glaring. Oh, you really screwed this up when you made this code change. But it didn't really tell us everything. So when I ran this end-to-end test at whatever 2,000 TPS, let's say I could get it up to, then I would find that one of my tiers would break. So let's say I'm going to pick on the rules engine. The rules engine, it just couldn't handle anymore. It's very CPU intensive. It fell over at 2,000 TPS. And we said, okay, well, we know our environment can do 2,000 TPS because our rules engine is kind of the limiting factor in our environment. And so the management came and said, well, how do I get to 4,000 TPS? Easy. Add another rules engine, right? No problem, just add another rules engine. But the problem there turns out to be, well, what if my NoSQL database can only do 2,500 TPS? I don't know that until I get that into production, right? I mean, I'll get my new rules engine in production and I'll run it up to 2,500 and I'll think, what the heck's going on? I can't get past 2,500. Well, my NoSQL database is now falling over, or whatever the other tier is that it might be. So we took this an extra step and isolated our tiers so we could determine exactly how much each tier, each physical piece of software could do on each physical piece of server. And so we would create our test driver, and one of the first things we tested, because it was kind of the biggest question in our environment, is how much could our messaging tier, how much could it really handle? Because it's fairly central to our environment. And so we just drove it as hard as we could until it broke, until it just stopped working anymore. And then we added another tier. In this case, we used the messaging tier to drive our rules engine tier because we knew it could outperform the rules engine. I don't want to add, I'm kind of contradicting myself because I said, well, isolate your tiers, but now I'm adding tiers onto each other. But the benefits of this is this looks more like production than if I created my own version of a test driver to test another tier. And I knew that my messaging tier is definitely going to outperform. I knew exactly what it would perform and would potentially outperform my rules engine tier, which it did. So we would push it hard until it died. And we said, okay, we know exactly how much my rules engine tier can do on this set of hardware. And like I said, we would stress test these. So we would stress test them until they broke. And now break can mean a couple things. You could break something where the application just quits working. It falls over, it seg faults, no recovery, no nothing, right? Or you could just push it until it just stops working, until it just stops accepting additional messages and it just doesn't go any further. So when you do that, you got to find the bottleneck. That's the big thing you got to find is where's that bottleneck at? Is it CPU? Are we just maxed out at CPU? Are we maxed out at I/O? Is it just a code issue? Is there something wrong with the code that's causing the problem? Those are all the things that we kind of looked at whenever we got to that point where we couldn't push a tier any further than what it was. Plenty of commercial tools to do this stress testing. We used both commercial tools and we built our own to kind of simulate transactions coming across the wire. One thing we did underestimate is when we built this environment out is sometimes our test drivers weren't strong enough to push our clients or our tiers enough. So we didn't have enough test drivers really push. So we kind of, at the end, had to build up some new test drivers and new machines to actually push the volume onto a single tier to make sure until it broke, until we found that breaking point. So that was one lessons learned that we had, because we didn't have enough test drivers. One thing, just a comment on a code level change that we found. We were using a library from another client, and we were pushing it hard, and we can only get it up to whatever TPS, some rate of TPS, but my CPU was fairly low, and we couldn't figure out what it is, but it wouldn't push any further. We ended up finding that they had a debugging setting, but we didn't specifically set a logging setting. So if you didn't specifically set it, they set it to debug, which seems, I don't know, I wouldn't normally do that. So it was logging things, but to nowhere. It was not going to disk, so we weren't seeing our disk fill up. Oh, there's debug messages. It was going to its backend array and logging all these debug messages to an array, and that array was blocking and ended up just stopping our application. So that was definitely one example we saw where the code of a vendor's library was causing us problems. Another tool that I want to talk about is tracking metrics. The tools that you can do to do this are everywhere. There's a lot of different ways to do this, but I think tracking metrics are an important part of performance. And it has to start in a couple places. First of all, in your application design. At the beginning of your thoughts of building this application, how big is it going to be? What am I going to do? How am I going to track this information? Am I going to put it in a database? Am I going to write it to a file? What am I going to do with it? How am I going to track it? And then define the important things that you want to track, right? I want to track volume. I want to track end-to-end time. I want to track each tier's time. I want to track how much time it takes to get to I/O. These are important to me because I think they're going to be maybe problematic. Now, important things can change, right? They're going to change throughout the life of your application. You know, I/O is now not a problem. It's SSD. You know, that's not a problem anymore. I'm not worried about that. I'm worried about this over here now. And so that's all going to change as you move through this. And then be able to toggle more detailed information as you go, and not, you know, I need to put a change request in and I need to bounce the server. No. You need to be able to do this, you know, easily. You know, at production runtime, something's happening. I want to see what's happening. You know, I'm at peak time. Where's my problems at? I'm going to turn on some debugging or some info level logging, and I want to see what's happening for, you know, 5 or 10 minutes or an hour without too adversely affecting my platform. All this kind of adversely affects it a little bit, but the benefits of having this tracking information is immense. Also, your server tracking, that was huge for us. We came in, there was very little server tracking that we had turned on. We ended up implementing some vendor code to do CPU and I/O, MP stats, all different things like that, and just kind of track those and graph them. And we found so many problems in our current platform because nobody looked. Nobody even looked. We could see 2 servers that should be doing the exact same workload, and this one was, you know, 50% CPU and this was 20. Or this one was, you know, had a you know, longer latency than this one, and we found lots of different reasons for that. But until anybody looked at it, it just went on forever, and we had bad performance because of it. And continual, this should be done continually, all the time. As I said, always. We should always be running this, because as soon as you go, oh, I need to know what happened because something broke or something's about to break, by the time you turn it on and the time you get it all running and working, the problem's gone away, more than likely. You know, and now you've missed your opportunity to grab the few little CPU metrics or I/O metrics that you needed to really find out what the problem was. And reporting and reviewing, obviously important. That's kind of what I mentioned about when we started tracking the CPU and Linux stats. And then the blame game. This is one thing I want to mention, is that how many of you guys have gone out and, you know, you're working with your application and you find a problem, you know, it's not working the way you want. You go, you know what that is? That looks and smells like a network issue, right? That's a network issue. It's got to be a network issue. Hey, you know, Joe, you're my network guy. I've got an issue. My application's having a problem because of network. What does Joe say? Not me. Let me look. Nope, I'm good. Network's good. Network all looks good. This is an application problem. And you go back and you look and you think, oh my gosh, is it? You know, I'm looking. It's got to be network. It's got to be network. It's got to be network. And unless you have these metrics, you know, we got a lot of pushback that same way. It's not me. It's not me. Whoever it is. It's not database. It's not network. Until we had these metrics and we said, hey, listen. You know, this one's tracking a lower latency than this one, or higher latency than this one. This one, you know, I looked at its max I/O, and it's 40 milliseconds higher than this one. Oh, you know, the storage guy finally goes, oh, we got a broken storage head. You know, what's going on? It's like, yes, that's the problem. So when you can have these metrics all the time, and you're always looking at them, and you can say, yeah, here's my problem. Here's my metric on my server that says this is the problem. Then it's a lot easier for those other people, if it's the network, to take a look and go, yeah, you're right, it is network. Let me take a look a little closer. But the main thing with the blame game is the first thing you should do is blame yourself. I think the first thing you should do is blame your application. You know, or if you're the network guy, blame the network. Whatever it is, that's who you should blame. You should look at yourself and say, is this me? Let me make 100% sure that this is not my code, and find all the ways that I can figure that out. I've left it all behind. It is definitely not my code. This points directly to, you know, network or database. I don't mean to pick on network guys all day, but maybe I will. You know, always look at yourself first, because you're going to lose so much face, right? When you blame the network guy, it's a network problem. Are you kidding? This is a network problem. And then 2 weeks later, you find out it's an application problem. Then all of a sudden, the next time you want to go to Joe, the network guy, he's going to probably not even look at your email or answer your call at that point. So always look at yourself. Make sure it's not you before you start blaming anybody else. So here's a finding I wanted to show. This is our MQ tier where the first time we started pushing it. So this is all of our CPUs on the server. And so we started pushing and pushing and pushing, and we got well past what they thought we were going to get to. So we said, oh, this is great. And like, we got 4 times, 5 times what they thought we would get out of it. We said, oh, this is great. You know, what results we got? We said, oh, let's go home. We're done. Well, we took a little look, if you can see that, a little closer look at it, and the server was only 40% utilized. It had 60% idle on the CPU. Thinking, we're pushing it. It's not going any faster. I mean, there's no way we can push it any faster. What's going on? As we look a little closer, one of the CPUs was totally maxed out, 99.9% maxed on that single CPU, which made us go, well, something's going on. There's definitely a problem with that CPU. Why is it? And as we look closer and we look closer and we look closer, the affinity level on that server was set up for the receives to go through one queue or one CPU, and the sends to go through a different CPU. And so those receives that we were getting, that we were pushing, the test driver that was pushing those messages to my messaging tier, couldn't push the MQ tier, couldn't receive the messages any faster. It was done. It was maxed out. He had one CPU. He was maxing it out. There was no way he was going to get any more to MQ that was sitting behind the scenes. MQ was sitting there going, give it to me. I'm ready. I'd like some more messages. But he couldn't do it. So we were able to change that and spread that that work across multiple CPUs. And then we jumped up again. We got 10 times as much than whatever anybody thought we might be able to do. So we were like, okay, we got through our CPU issue and things look better, but we're still only at, if you look at the right side of this graph, we're only at 60% CPU. What the heck? What's going on? You know, and we realized now we're at a code issue. We're at a library issue with MQ. MQ on that device could only handle, this rate, 80-some thousand messages per second with one queue. And so we started playing with how many queues, how many queue managers. What if I put 10 queues or 100 queues or 2 queues? We've realized it didn't really matter. As long as it was more than one queue, 2 queues on the same queue manager, 2 queue managers, or a whole bunch of queue managers, didn't really matter. Then we could finally push it up and get it at least closer to the 90% range. We could probably squeeze a little bit more out of that. But that was really to the point where, like, okay, we feel pretty good about where we're at. That's a good number. Everything's running pretty good there. So this is all about, we found a lot of different little pieces, hardware and then software issues, and we just had to drive through those and get past those bottlenecks. Let's see. So I'll talk a little bit about garbage collection. Monica Beckwith yesterday had a great presentation on garbage collection, so I'll let her talk a little bit more about that. But one thing we did see, Java and low latency are not friends, right? They don't go really well together. They don't. There's a lot of pauses. There's a lot of garbage collection. Young garbage collection stops the world. Old, full garbage collection stops the world. It's all over the place. I didn't want, even a 20 or 100 millisecond pause was painful for us. We wanted flat. That was our goal. We wanted a flat response time. No matter what it was, we wanted it flat. And Java hotspot really had an issue with, I'd get a 5 second, then I'd get a 3 millisecond, and then I'd get 100 millisecond. I was all over the place, and we really couldn't handle that. And it wasn't the speed of Java. Java was fast. It was when it had to pause to do its garbage collection. So when I came in and I just started looking at this, we had nearly 10,000 major garbage collections in our environment a day. 10,000 fulls a day. So that was a big deal. Over 6 hours was spent in full garbage collection of all my processes. I mean, there was a lot of processes, maybe that wasn't a lot, but that seems like a lot of time. 6 hours where it's going, hey, everybody, just wait. Everybody hold on, take a break. I gotta take out the garbage. Everybody just chill out. And so that was a lot of time. That's not even including the minors, that's just the majors. So those are all, they cause problems in our environment, they cause transactions to time out. And for MasterCard, every transaction matters. Every transaction we want to look at. We want to know what it's like. We want to be able to see if it's fraudulent and then move on. And so when we drop any of those on the floor, that's a problem. And so obviously our goals to remove them, our initial goals were, okay, we want to get rid of the majors. So we were using a lot of old parallel GC, and we said, well, we got to get rid of that. Let's use CMS, that'll be a lot better. And we did, and it was a lot better. I mean, it took away a lot of our major fulls, and we wanted to limit the minors to as short as we can, so make those run really, really, really fast. without promoting everything into old, which then would cause a whole nother problem, all to improve our SLA. So we worked on this and we tuned and we worked with our vendors of the libraries we were using, and they said, man, you have got this tuned to the best that you can tune. We had enough memory, we had enough CPU, we had everything, and it still didn't give us what we wanted. We still couldn't get that low, tens of milliseconds flat response time that we wanted. So we kind of gave up on Oracle and Hotspot and IBM's, everybody else's, and we ended up buying Zing. And that's Azul's, and I can't remember her name. Earlier, the keynote this morning, she talked about Zing versus Hotspot. And so if you look on the right of this, our test for hotspots, this is a max pause or max response time during a test, which are all relate exactly to pauses. And you see some of these, I had to cut the graph off at 6 seconds because Hotspot would have these huge swaths, that would go up and down and all over the place. And so this is a second, and so most of my maxes for a particular minute were 200 milliseconds. That was a lot for us. That was way over what we wanted to do, and so we ended up implementing the product called Zing. And as you see, it's nice and flat. There's some humps and bumps, but for the most part, it is nice and flat across the architecture. So we liked that a lot better. So that was a great tool for us to use. Okay, third principle, strategery. So the big thing that people stop with when they do performance testing, I think, is after they get everything tuned and everything working the way they want it, they say, I'm done. We're done. And the management says, and the business says, you did it, right? You're done. Your project's done. Performance project is complete. We should be able to move on. Well, I think we need to go a step further than that. And that's what we started to do, because we got a lot of questions from our business about, well, I've got some new business we want to, I've got some new work that we want to do. It's, it may bring on another 100 TPS or 1,000 TPS, or they think big. It's 1,000,000 TPS. We're going to be so big. We're going to do everything. And it's like, they say, well, will the platform handle that? Will the platform handle that? And we, a lot before we started modeling it, I don't know. I think it can do another 5,000. Or what if this server came in? Or what's happened over the last 6 months? I don't know. Have new rules been implemented that are more expensive than the old rules? Are we using more memory than we were using? I don't know. We got to go look at everything again. So we stopped and we said, how do we model this? And what we did was we took what was happening currently in production, and we said, okay, what's the volumes? What's the CPU look like? What's the I/O look like? Where are our barriers? And we created kind of an application in Excel. It was a little crude at the time, but where we said, okay, this transaction on this tier takes this amount of CPU or this amount of memory or this amount of I/O. And we were able to kind of calculate that up into kind of a health, the current health of what we thought production looked like. And so that was kind of our first swath at what a model would look like. But we said, well, we can't just stop there. We got to think about this a little further. So we said, let's start, as we're doing our performance testing in our Pete environment, and we're doing our tier testing, we can look at that a little closer and say, how is this looking compared to what production's looking like? I'm running this test at 1,000 TPS. Does this look like production at 1,000 TPS? If it doesn't, maybe I needed to adjust that to make it look like that, and then grow it and see how hard I can push. So a lot of these tiers, we thought, from a production model, look great. This one's running at only 20% CPU, and it's it's doing 1,000 TPS or whatever. We've got plenty of room to grow. But then we found, where we can only get to 1,500 TPS, like the debugging example I had a minute ago. It looked great up to 1,000. It didn't have any issues, but you got to a certain point, it just fell over, even though there was plenty of CPU available. So that's when we took that performance data and we intermixed it and we compared it with what we're seeing in production, and we were able to come up with a more refined version of what that's supposed to look like. And then every month or so, we go look at production, we look at production volumes, we look at those graphs that, that are running all the time, continually, and we look at the CPU and we say, our model says CPU should be 32% based on that production volume. What's my CPU? It's at 62%? Something's wrong. Some model's off, somebody broke something in the code, a configuration wrong, I/O's broken, something's awry. Let's go look at it and figure it out. So this is something that, if you're trying to do this, to make sure as you're doing this testing, make sure that this is never done. Make sure your management, your business knows this is something we got to keep continuing down the road for. And then one of the best ways we looked at 100 different ways to try to show this to the executives, and how does this look, and when do I need a new server? And we had all these graphs and bubble charts and all this junk, and none of them looked right. You couldn't really understand them. We had a lot of tiers in our environment and what it's going to look like. And this was the best one. So this is something, if you're trying to do the same thing, this might work. So this is basically our tier and our dates going across, and just a heat map, a simple heat map of what that looks like in the future. And this goes on, a couple years, however long I want it to go. I can just push it down a couple years and see what that's going to look like. And obviously, your eye pulls to the red, right? That's what I'm trying to pull your eye to. Where's the red coming? So if it was February of 15, and I could say, listen, we're modeling this out, we're looking at something, our rules tier looks really bad in May and June. We need to do something about that. And at MasterCard, we don't have servers just laying around. We can go pick up and plug in somewhere, because we have to order things and get them in. And so it's like, I need a few months to get all that done and get it in and have all the different people plug all the wires in that need to happen to implement something. And then as you see, like in July, that's when I implemented that server, or whatever it was that we implemented. I could easily in my model say, I'm going to add some more capacity on this date, and then show what that looks like. And so it was easy when the business came to me and said, hey, I need to do another 1,000 TPS or 1,500 TPS. Can you do that? And then I can just plug those numbers in and say, okay, what would 1,500 more TPS do to all pieces of my environment? And it would show me some very interesting things at times. But this was the best way we were able to visualize that with the team. And then obviously, the thing that you have to keep moving with this is, create some cool dashboards. You got to create some cool dashboards. They love them. Management loves them, and we can't get too far without funding. And we need funding, right? We need money to do all this work, and if we don't have it, we can't do it. And if the management's not excited about it, it's harder to get the money. But if they've got cool dashboards to look at, then they love it. They eat that stuff up. They're like, oh, that's cool. Look at the bar graphs and the pie chart. What's that pie chart telling me? I don't know, but it looks good, No, we explain it to them. We actually talk stuff like this through with them. We say, listen, this is what this is telling you. We want you to go look at this. We're giving you access to this data, real time or every month or whatever it is. Go look at it. This is what this is telling you. This is telling you this is bad or good or indifferent, whatever it is. This is what you should be looking at. When that turns red, that's a problem, And it was a little more technical, but it got them more involved. It got them understanding what we're doing and why we're doing it, And I think that really helped, along with the heat map, but this is just enough to kind of get them involved and moving. So my final slide here is those steps for success I mentioned earlier. So these are the three things that I think you have to do that we miss so many times to get that funding from our management, to get them to explain to them what the problem is and how to fix it. So the first thing, obviously show the problem. Don't explain them the problem. Don't sit in a meeting and go, listen, here's what's going on. The CPU is too high, and this thing's not working that way, and the flux capacitor's broken, and whatever it is, because it's going to go like this over them. They don't get that, right? They don't get that. But if you put it in a simple graph of some sort, we had it where we were getting full GCs. And every full GC, I could pinpoint that full GC exactly to the time when I had a timed out transaction all day long. It was beautiful, beautiful graph that was put together. And I was able to show that to him. I go, see, this is what's going on. Here it is. You don't want transactions timed out? Here's the problem. And I'm showing it to you in a nice graph. They saw that and they understood it. It made sense to them. But you can't just stop there. You got to have a solution. Before you give them the problem, give them the solution. All we have to do is implement CMS or implement Zing or implement whatever to fix this issue. Okay, so give them what the solution is, how it's going to work, what it's going to do, and then big point, follow up results. Follow up with the results after you've implemented the change, which might be a week or a month or 6 months, however long it is in your environment or whatever kind of change it is. Follow up with the results. Rebuild that graph or re-show what you had. This is what we had in January. Remember all these timeouts we had? We had 10,000 timeouts a minute. Now we've got 3 because of this one change I put in. Wow, really? That's another cool dashboard. I love that. Here's some more money. And they just start opening their wallets and they start throwing it at you when that happens. But yeah, I really do think these are the big things. These are simple, but and they take some discipline. But when you do these and you follow up with that and you really explain what's going on, why it's going on, and the results of what you've done, then it goes long, long, long way. That is it for me, for everything I've got, at least in slides. I don't know how much time we've got, but for questions or comments or throwing anything, yes.
Maybe just a clarification on the heat map. That's forward-looking, so you're based on what you think the load will be in 3 months, 6 months, whatever.
Yes.
Okay,
So he was asking, is it forward thinking? Is based on the load? So yeah, so we would take just organic growth that we see, in our environment as new cards are added. And then we also took input from our business. Hey, we've got this job that we think is going to sell in February, and it's X amount more volume. We've got the safety net volume coming on. It's X amount volume. So we were just able to push that down the line. Yes?
I love by using dashboards to communicate things to other members of the company and communicate to companies. Do you tend to have separate dashboards, separate visualizations for, say, like management which relate to specific business metrics and KPIs, or do you kind of do engineers and management kind of share? Is there a lot of overlap between this team?
Okay, so the question is, for the dashboards that we build, do we have an executive level dashboard and middle management dashboard and engineering dashboard, that kind of thing? Yeah, so yes, that's where we're heading. This is all kind of brand new, getting all this in and getting all this working. But yes, right now we've got executive management dashboards like this. We've got low level, what's happening on this CPU at this point, type of metrics and dashboards all across. Another tool that I'll not paid by them or anything, Splunk has turned out to be a great tool. I don't know if anybody's used that yet, but that is a really cool tool to pull all your logs and all your metrics from lots of different places and aggregate it and visualize it. It is a pretty cool tool. They have a free version that you can use and start playing with, but it's pretty neat. Any other questions? Yes?
Do you find it's better to try and integrate your performance teams in with development teams, or do you keep them as a separate engineering practice that focuses just on that?
We separate the performance team who does the actual testing and evaluation from the development, and the only and we intermix them and we talk, right? It's not like there's big walls between us. The question was, do we break the teams up between the performance team and the development or the engineering team? And we don't. We do because if they wanted me to be a tech lead on an application project, and that got busy, then I wouldn't spend any time doing performance engineering. They would say, don't worry about that, not a big deal. We need this done because it's due next month or next week or tomorrow or Monday, and don't worry about this for the next couple days or next couple months. And then all of a sudden, we're not spending any time on it. So we're trying to really specify this team is doing performance engineering. They're looking at this, they're trying to break it every day, every month, and figure out what the problem is. Because if not, we're just going to get pulled into development, and then we're just going to quit doing it. Anything else? All right, thanks a lot for coming. Appreciate it.